Hi y'all, in this video we'll continue to look at determining if arguments are valid. In this example, our argument is if a healthcare reform bill passes, then the bill must have been a good bill. No healthcare bill passed, thus there was no good healthcare reform bill. If I look at this, I can choose P to be a healthcare reform bill passes, and Q to be the bill must have been a good bill. So premise 1 is if P then Q. Premise 2, no healthcare bill passed is not P, negation of P. Premise, the conclusion, thus there was no good healthcare reform bill, should be not Q. Next, we'll determine if this argument is valid. Continuing with this example, we see that our premise 1 was if P then Q, premise 2 was not P, and the conclusion was therefore not Q. In this example, we want to use the standard form of argument table to help us determine if this is valid. Make sure that you're looking at your standard form of argument table at this point. You should notice that this matches exactly with number 6, the fallacy of the inverse. That is, this argument is not valid based on that table. Example A was also the argument from the second video on determining if arguments are valid, and you can see how we saw using a truth table that this argument is not valid, but you can also see it directly from the standard form of argument table. In the next few examples, we'll look at several other examples from the standard form of argument table. In this example, the argument is it's an election year. If I voted, then it's an election year. Therefore, I voted. Let's take it's an election year to be P, and I voted to be Q. That tells us that premise 1 is P. Premise 2 is if Q, then P. And the conclusion I voted should be Q. Next, we'll determine if this argument is valid. Continuing with this argument, we see that the argument can be set up as premise 1 is P, premise 2 is if Q then P, and the conclusion therefore Q. Looking at your standard form of argument table, you should notice that none of the arguments exactly matches this. Well, first we should notice that this argument is equivalent to the result we get from the truth table given by this statement. Now, within this part right here, we have an and statement. Now, we discussed earlier the fact that the and statement doesn't care what order the arguments come in. That is, I could have set this up as this. That is, I can change the order of the premises. And I want to do this here. Let's put premise 1 into premise 2's spot and premise 2 into premise 1's spot. You can always do that. You can reorder these. Now looking at this reordered set, well, those aren't quite exactly on the standard form of argument table either. So we're going to need to do one more thing with this. And this boils down to recognizing something else that's true about these arguments. If you look at the standard argument number 1, it's of this form. Premise 1 is if P then Q. Premise 2 is P. The conclusion is Q. Alright? Well, what this is really saying is if the first premise is of the type first thing, then second, and the second premise is the first thing, the first statement, and the conclusion is the second statement, then that's a valid argument. Alright? These show the same underlying idea. If there's first thing, then the second. The first thing, therefore the second. Right? It doesn't matter whether I use P's and Q's or 1's and 2's or circles and stars or happy faces and moons. It all means the same thing. Right? It's about the relationship we see underlying this. In fact, if we look at the standard form of argument tables, all of the arguments that start with an if then are always of the form if P then Q. That is, if the first thing then the second. So let me do it in terms of 1's and 2's here. So the argument here, so taking this down here, let's rewrite premise 1 as if 1, then 2. That is, I'm calling Q1 and P2. The second premise then is 2. Therefore, well, Q is 1, therefore 1. Looking closely at this relationship, you may already see the answer in the standard form of argument, but taking this one step further, again recognizing that all the standard form of arguments that begin with an if-then statement start with P, I could say this is if P then Q, therefore premise 2 is Q, therefore P. This argument is identical to the original in terms of its validity. You should see this as argument 5 on the standard form of argument. That's the fallacy of the converse, and this is not valid. For the next example, let's look at the argument either I'll go for a run or I'll go biking. I went for a run, so I did not go biking. Here, I'll go for a run will be P. I'll go biking will be Q. That makes premise 1 P or Q. I went for a run. P is premise 2. So I did not go biking, not Q, is my conclusion. Next, we'll determine if this argument is valid. Continuing with example C, we see the structure of our argument right here. Looking on your standard form of argument table, you should see this as number 7, the misuse of disjunctive reasoning, which is not a valid argument. We see that this is not valid. In this example, the argument reads, if Peter climbs up the stairs alone, then his dad will get in trouble. If Peter's dad gets in trouble, then Peter will get in trouble. Therefore, if Peter climbs up the stairs alone, then Peter will get in trouble. Here, we're going to take P to be Peter climbs up the stairs alone. If his dad will get in trouble, will be Q. So the first premise there should be if P then Q. The second premise, Peter's dad gets in trouble, that was Q, then Peter will get in trouble. This argument actually has 3 different simple statements. We'll call this one R then. And that second premise, if Peter's dad gets in trouble, if Q, then Peter will get in trouble, R. The conclusion, therefore, if Peter climbs up the stairs, that was if P, then Peter will get in trouble. Peter will get in trouble was R, so if P, then R. Notice, an argument can be made up of any number of simple statements. Next, we'll determine if this argument is valid. Continuing with example C, we see the structure of our argument right here. If P then Q is premise 1, if Q then R is premise 2. Therefore, our conclusion is if P then R. You should see this as the fourth argument, the law of syllogism, otherwise known as transitive reasoning. This is a valid argument. This last example shares many similarities with the previous example. Here, the argument reads, if Peter climbs up the stairs alone, then his dad will get in trouble. If Peter's dad gets in trouble, then Peter will get in trouble. Therefore, if Peter gets in trouble, then Peter climbed up the stairs alone. As with the last example, let's take P to be Peter climbs up the stairs alone, and Q to be his dad will get in trouble, and R to be Peter will get in trouble. Our first 2 premises are again, if P then Q, along with if Q then R. The conclusion, however, if Peter gets in trouble, that's R. If R, then Peter climbed up the stairs alone, that was P. So this gives us a slightly different set of premises and the conclusion really being the only part that's different. Let's see what that does to our argument as we go to determine if it's valid. Continuing with this last example in this video, we see the structure of our argument here. Premise 1 is if P then Q. Premise 2, if Q then R. Therefore, the conclusion that if R then P. Looking on the standard form of argument table, you should see this as number 8. which is the misuse of transitive reasoning. So this argument is not valid. To reiterate, many of the common arguments we'll see are on the standard form of argument table. Not all are, however. So sometimes truth tables are the only method we have for determining the validity of an argument. Have fun with logic.